This video will be about solving systems of equations with three unknowns. There are two ways to solve systems of equations with three unknowns that we're going to be working with. The first is substitution. So when you're solving by substitution, the first thing you need to do is you want to look for one of the letters, any of them, x, y, or z, that does not have a coefficient, does not have a number in front of it. So like this first term 3x would not work for us because there's a 3 in front of the x. It has a coefficient. So if we look through all of these, the best variable for us to use is this plus y variable. It's all alone, no coefficient in front of it. So once you've found that best variable, that's the one we're going to solve for. So for now, ignore equation 1, I'm going to call it, and ignore equation 3. And focus on equation 2 and get y by itself. So looking at just equation 2, we would like to get the letter y alone. To do that, we're going to have to move the negative 2x and the negative 3z to the other side. So I would need to add 2x to both sides and add 3z to both sides as well. So that gives me y equals, and then I can't combine any of those together, none of those are like terms, so I just write them side by side. Negative 4 plus 2x plus 3z. Once you have isolated that letter y, now is where we go back to equation 1 and equation 3. So equation 1 is our 3x plus 2y plus 4z equals 11. I'm going to give equation 3 a different color, just so it'll help us keep track of things a little bit better. So let's make equation 3 blue. So equation 3 is 5x minus 3y plus 5z equals negative 1. Now in both of these equations, we're going to take what we found for the letter y, or it could have been another letter. Maybe we replaced the letter x, or we solved for the letter z. We're going to go replace the letter y in each equation with that information we just found. So we would get 3x plus 2 times negative 4 plus 2x plus 3z. And then we still have the rest of the equation, plus 4z equals 11. Same thing with our equation 3. We replace the letter y with all of that information. Negative 4 plus 2x plus 3z. And then we still have everything else after the letter y to still write down. Plus 5z equals negative 1. So for both of these, I need to simplify as much as I can now. When you have parentheses, you must distribute first. So we only distribute the 2 because it's the only number touching that first parenthesis. So we have 3x minus 8. 2 times negative 4 is negative 8. 2 times 2x is 4x, and 2 times 3z is 6z, plus 4z equals 11. Sorry, I don't know why it does that sometimes. Ah, come on, there we go. Now we combine any like terms on the same side. So on the left side of the equal sign, 3x and 4x will combine, gives me 7x. 6z and 4z will combine, that gives me 10z. Negative 8 does not have anything to combine with, so it's still there. And then we want to combine any like terms on opposite sides. So now let's move the negative 8 over to the other side. So we get 7x plus 10z equals 19. Okay, good so far. Now we go to our second equation, or sorry, I should say our third equation. There are a lot of equations going on, so it's easy to lose track of them, which is why I labeled them. So equation 3, we want to do the same process and simplify. So we have 5x, negative 3 times negative 4 is positive 12. Negative 3 times 2x is negative 6x. Negative 3 times 3z is negative 9z. Again, we combine like terms. 5x minus 6x is negative 1x. Negative 9z plus 5z is negative 4z. We still have our plus 12 equals negative 1. And then we minus 12 from both sides so that all our numbers are combined as well. All our terms that don't have variables. So now we have to go through our process again. Just like up here where we had to get the letter y alone, we want to look at these two equations. Let's call them equation 4 and equation 5. These two equations, we want to get one of the variables alone. This time, we have a little less flexibility. There's no one letter that has no coefficient. So I'm going to pick the one with the smallest coefficient. I'm going to pick the letter x over here on equation 5 to get alone. So to do that, we're going to have to add our 4z to the other side. We get negative 1x equals negative 13 plus 4z. And then we're going to get x alone by dividing everything by negative 1. So x equals positive 13 minus 4z. So now we have our letter x alone. Again, we're going to do substitution. We're going to take all the stuff we got for letter x and go put it into equation 4. These problems are just all over the place. It's hard to keep track of. But there's no better way to organize it. 13 minus 4z, that I know of at least. We're replacing the letter x with 13 minus 4z. And we still write everything else down in the equation. And now we distribute again. 7 times 13 is 91, minus 28z plus 10z equals 19. So the whole purpose of this entire process was now our equation itself only has one variable. Now we're down to just the letter z. You may get down to a different letter. Maybe you're down to just the letter x or just the letter y. Whichever letter you're down to, we're down to the letter z, and we're going to solve for it. So first I'm going to combine them together. Negative 28z plus 10z is negative 18z. We've got to get rid of the 91, so I'm going to minus 91 from both sides. Need a little more room, so I'm going to extend my page. Negative 18z equals negative 72, I believe. Yep. And then we divide both sides by negative 18. So z is 4. That is one of our answers. Now we're going to go back and we're going to replace in some of our other equations. So I always look for the equations where we said, okay, this is what the one letter equals. So going back to our equation for letter x, we know x equals 13 minus 4z. Well, I just found z. So I can plug it in. Instead of writing z, I'm going to write 13 minus 4 times 4. And simplify. 4 times 4 is 16. 13 minus 16 is negative 3. There's our second answer. So now I'm going to go back and look through our equations and look for the one that says y equals. Now really, we could plug them into equation 1, 2, or 3 and use those. But since I already have y alone, it's easiest just to use the equation that says y equals negative 4x plus 2x plus 3z. So replacing again, we have negative 4 plus 2 times, I'm going to have to scroll down, x was negative 3, plus 3 times, z was 4, and we multiply. 2 times negative 3, so negative 4 is still there. 2 times negative 3 is negative 6. 3 times 4 is 12. Negative 4 minus 6 is negative 10, plus 12 is positive 2. So there's our third answer, y equals positive 2. Now when we write our answers, we write them as a coordinate in our three-dimensional plane, but our coordinate is still alphabetical, so we still start with the letter x, negative 3, then use the letter y's number 2, then use the letter z's number 4. So our absolutely 100% final answer is negative 3, 2, 4. Next, we're going to solve using elimination. So elimination, the start is a little bit different. We want to look for anything that has the same coefficient on all three equations. So looking at our x's, our coefficients are 1, 2, and 4, all different. On our y's, negative 3, 3, and negative 3. Good start because they all have the number 3. Z is 3, 1, and 1, still far away. So we're going to focus on these y's. So we want to group them in sets of 2, group the equations in sets of 2, so that when we add the equations together, the y's would cancel out. So we want them to have the same number in front, but different signs. So like equation 1 and equation 2, it would be good to group those two together because they have the same coefficient, but different signs. Same thing with equation 2 and equation 3. Same coefficient, but different signs. So, doing those groupings, I'm going to write them completely separate from this start of the problem. We have equation 1, x minus 3y plus 3z equals negative 4. Equation 2, 2x plus 3y minus z equals 15. So that was equation 1 and equation 2 grouped together. We're going to do the same thing with equation 3 and equation 2 and equation 3. 2x plus 3y minus z equals 15. So there's our equation 2, and we're going to group it with equation 3. Okay. So now what we're going to do is we're going to add those two equations together. We're going to combine them. So adding them together, 1x plus 2x is 3x. Negative 3y plus 3y is 0y. So that's our goal. We want those, or any groups of letters, to cancel. We wanted the y's to disappear completely for both sets of equations. 3z plus a negative 1z is 2z. Negative 4 plus 15 is 11. Now we do it again with our second set of equations. 2x plus 4x is 6x. 3y plus negative 3y cancels each other out. Negative z minus z is negative 2z. And 15 plus 19 is 34. So now, these two new equations we got, we'll call them equation 4 and equation 5. We need to group those two equations together. Our ultimate goal again is to get down to where we only have one letter left. So we're going to take our 3x plus 2z equals 11 and group it with our 6x minus 2z equals 34. So we grouped equation 4 and equation 5 together. We're going to do the same process. We want to look for the letters that have the same coefficient with opposite signs. I'll show you another problem on the next page, what happens if none of those exist. You might have to change some stuff, but for us, we're good to go because our z's have the same coefficient, a 2, but opposite signs. So we do the same process, add them together. 3x plus 6x is 9x. 2z minus 2z cancels out. And 11 plus 34 is 45. Now we're down to a simple equation to solve. I want to get x alone. I'm going to divide both sides by 9. So x equals 5. Once we know what x equals, we're going to go back through and substitute again to find the other variables. Now this time, so on substitution, we kind of picked the equations that worked best for us. This time there is no best. I just want to go plug our x back into, and I kind of think of it as our previous step. Our previous step was working with equation 4 and equation 5. I'm going to plug it into either of those. No matter which one I choose, I should get the same answer. So let's choose equation 4. On equation 4, we have 3x plus 2z equals 11. I'm going to replace the letter x with what I found for x, which was 5. And I'm going to go through and solve this equation now for z. 3 times 5 is 15. I'm going to have to do some opposites. I'm going to minus 15 from both sides. 11 minus 15 is negative 4. Divide both sides by 2, and z is negative 2. So we're almost there, 2/3 of the way. Now we just need to solve for the letter y. Now I have to go back to my original equations and choose from either equation 1, 2, or 3. Again, I can pick any of them. It doesn't matter which one I choose. So for our last step, I'm going to pick equation 1. X minus 3y plus 3z equals negative 4. Now I'm going to have to replace both the letter x and the letter z. X was 5. Z is negative 2. Sorry, my z's are kind of funny looking, so that's why I put the little line through them. 3 times negative 2 is negative 6. We would combine our like terms. 5 minus 6 is negative 1. And now we start doing our opposites. Add 1 to both sides. And divide both sides by negative 3. So y is equal to positive 1. Again, we write our answer the same way, with x first, y second, and z third. Okay, our last step is elimination again, or our last type of problem we're going to talk about. But this time, we don't have 3 coefficients that match. X's are all different. Y's 2 are the same, but 1 is different. And Z's, same thing, 2 are the same, but 1 is different. So we're not going to go through this whole problem. We're just going to talk about, well, how do I change this so then I could go through the process of elimination? So when this happens, you can actually change these equations by multiplying everything by the same number. So, for example, we said the y's were pretty close. This one has a negative 2, this one has a positive 1, this one has a positive 2. We want to change this middle one to also be a positive 2y. So, right now it's a positive 1y. I'm going to multiply every single number by a positive 2 so that it would become a positive 2y. So multiplying that out, I get negative 8x plus 2y minus 4z equals 2. I multiplied everything by positive 2. Then I just bring all my other equations over. And now you can decide how to group everything so that when you add them together, all the y's would cancel out. So that finishes our discussion on solving systems of equations with three unknowns using substitution and elimination.